Hello everyone, welcome to this next question from integral equation. This question is from December 2019 consisting of 3 marks. The question is, let phi be the solution of this equation. This is the Volterra kind of equation, right? Moreover, the given kernel is of convolution kind because here x minus t term is appearing and x minus t whole square term is appearing. Then they are asking what is the value of phi of 1 among these 4, right? So we have an idea about how to calculate this convolution kind of kernel. Let us see how. So our kernel here in this case is kxt, that is equal to 3 plus 6x minus t minus 4x minus t whole square, right? So we can write this equation in this form. Phi of x is equal to 1 minus 2x minus 4x square, that means these terms as it is, plus, and here we can, instead of this whole term, we can write this as 3 plus 6x plus minus 4x square, right? Minus 4x square. This whole function convolved with phi of x. Now how this term appears from this term? Because it is due to the definition of convolution, because if we have two functions f of x convolved with the sinus for convolution convolved with g of x, that would be equal to integration from 0 to x f of x minus t gt dt, right? So this is the definition of convolution operator. So that means you just have to replace x with x minus t in the first function, and in the second function you just have to replace x with t, and you take the limits integration with respect to t, limits varying from 0 to x. So we can write this in this form. So that now what we can do, we can take Laplace transform on both sides. So what would we obtain? We obtain the Laplace of phi of x is equal to the Laplace of this whole term 1 minus 2x minus 4x square, right? Plus the Laplace of this convolution term 3 plus 6x minus 4x square convolved with phi of x, right? Now in this Laplace transform, we know another result. What is that? The convolution of the Laplace of convolution of two functions, that is simply equal to the product of the Laplaces of individual functions. So here it would be Laplace of f of x multiplied by the Laplace of g of x, right? This I have told you in the earlier videos also. So let's get it done. So Laplace of phi of x as it is, right? And here, because Laplace is a linear function, so Laplace of 1 minus 2 times Laplace of x minus 4 times Laplace of x square, and here it would be Laplace of this term multiplied by Laplace of this term, right? So the Laplace of 3 plus 6 times the Laplace of x minus 4 times the Laplace of x square multiplied by this whole term multiplied by the Laplace of phi of x, right? So this is the thing. So we can take this term common, right? We can move this term to the left hand side. So we have Laplace of phi of x 1 minus this whole term. So what would be that? 3 is also taken out, and the Laplace of 1, what is that? The Laplace of 1 is equal to 1 by s. The Laplace of x to the power n, that would be equal to n factorial divided by s to the power n plus 1. And yeah, that's all what is required in this question. So it would be 1 minus 3, right? 3 by s. Then plus 6 times the Laplace of x. What would be that? 1 by s square. Minus 4 times the Laplace of x to the power 2. That would be 2 factorial divided by s to the power 3. Right? And in the right hand side we have the this terms, right? So Laplace of 1 is 1 upon s minus 2 upon s minus here it would be x square. So it would be 2 factorial divided by s cube, right? 4 times of this thing, right? So the Laplace of phi of x, if we simplify this, what would be that? It would give us s cube minus 3 s square minus 8 divided by s cube, and here we would have s square minus 2s minus 8 divided by s cube, right? So what would be phi of x? Laplace of phi of x would be equal to, this term cancels with this, so we are remaining with s square minus 2s minus 8 divided by s cube minus 3s square minus 8, and we can write the denominator as this. If you observe, s is equal to 1 is a root of this equation, right? So when you divide by s minus 1, we can factor this equation like this: s minus 1 multiplied by s square minus 2s minus 8. So basically this terms cancels with this. So we have Laplace of phi of x equal to 1 upon s minus 1, right? So now how to take the Laplace inverse? Next step is to take the Laplace inverse on both sides. So we obtain phi of x is equal to Laplace inverse of 1 by s minus 1. Now it is similar to calculating the Laplace inverse of 1. We know the Laplace inverse of 1 by s. It is equal to 1. We all know that, right? But here instead of s we are having s minus 1. So we can use the first shifting property or the inverse of first shifting property. What is that? The first shifting property, it states that the Laplace of e to the power ax into some function of x is equal to f of s minus a, where what is f of s? Where the Laplace of f of x is equal to f of capital F of s. That means you first calculate the Laplace of the function multiplied by e to the power ax. That means this. Call that as capital F of s, right? And then whatever is the domain, whatever is s here, you just replace that s with s minus a. That is the coefficient of x in e to the power ax, right? So in this case we have to apply it in the other direction. So we will obtain, we can write this as e to the power 1x into the Laplace inverse of 1 by s, right? And what would be that? The Laplace inverse of 1 by s, we already know it is equal to 1. So our phi x simply is e to the power x. So this is our solution, right? But in the question they are asking, what is phi of 1? So if we substitute phi is equal to 1, so we'll have e to the power 1 here, right? So our answer would be e to the power 1. So option C is the correct option. That is it for this video.